Oh, good morning. Hello. It is Tuesday, yet another Taco Tuesday here. It is the 26th of May, and we'll get started today. And today's lesson, the first thing I want to talk about are exceptions to the octet rule. These are things that don't form a normal octet. And the way that you can kind of tell is two things. First of all, if you add up your valence electrons here, nitrogen has 5 valence electrons, and each oxygen has 6 valence electrons. And that adds up to 17 electrons. That's odd, as in that's an odd number. So that's how you can tell if you have an odd number. So with this, we're going to put the nitrogen there in the middle and give it its 5 electrons like that. And then we're going to throw an oxygen here on this side. And we'll make a double bond like that. And then we'll put our other oxygen over here. And we will make a single bond like that. And what we have is the following. We have 8 electrons now on the nitrogen. We have 8 on the oxygen, but we only have 7. We don't have a full octet on this other oxygen. So that is a problem. Very unusual. By the way, NO2 is a poisonous gas. Here, boron is always short. Boron only makes 3 bonds. So if we draw boron like this, B, and give it its 3 electrons, we usually do that and kind of make them a Y shape like that, and then we will simply bond it to the 3 fluorines around it, and it will make a set of bonds like this. Now it has 3 electrons. Each fluorine has 7, so that'll be 21 electrons for 24 total. And each of the fluorines will have a stable octet, and the boron will be satisfied with 3. So boron, 3 bonds, and that's the way it is. Boron never wants to have an octet. It only makes 3 bonds like that. Okay. Other exceptions to the octet rule. When stable molecules form and not all the nonmetals obey the octet rule, hydrogen is one of these things. Hydrogen has the duet rule. It only forms one single bond, which is 2 electrons like that. Boron, as I just said, makes 3 bonds because it has 3 electrons. Phosphorus has 5 electrons, and it's in the third group. And I'm just going to start with this. Phosphorus can make 5 bonds, and that is going to exceed the octet. So it can go past the octet, and so can sulfur. Sulfur is capable of making an almost crazy 6 bonds. So these two elements specifically can exceed the octet like that. We will look at these in specific one entire lesson today, or not today, this week. Okay, what does VSEPR stand for? The V stands for valence. The S is for shell. E is for electron. The P is for pair. And the R is for repulsion. Now, I don't know what you picture in your mind with an electron, but all electrons are equal. Because all electrons are equal, they want to be as far apart from each other as possible. So if I put X here as some mysterious element, and I have a single electron on this side, where should the second electron be? If you said over here, you would be correct. Electrons want to be as far apart from each other as possible. All right, and that's what lets these shapes happen. So VSEPR shape allows these shapes to happen. Now, what is hybridization? Hybridization is where electron orbitals will hybridize. So what they do when they hybridize is they will combine shapes. Remember when we talked about orbitals, we had an s orbital, and we just drew a single line like that. And then we had a p shell that contained 3 orbitals, 1, 2, 3 like that. So when you look at this, there's one s and there's 3p. So sp3, that means we've got 4 orbitals total. and they're going to share the characteristics of 1s and 3p's. So they're going to hybridize together so that they are equal. Why do things hybridize? Why? So that all bonds are equal. Every bond needs to be equal, and they will all be equal distance apart. Let me show you some slides on this. So here, this is 1s, and this is 1p, and they are going to hybridize together to make this, and now this is sp. Go back and don't do that. This is sp, like this. Both of these will be equal. Oop, wrong way. Here, sp2, we've got 1s, and we've got 2p orbitals. They're going to hybridize to make 3 orbitals, 1s and 2p's. They're going to hybridize together to make sp2 hybridization. We'll see this when we see 3 bonds. sp3 is where we have 1s and we have 3p's together, and they will now hybridize to make this sp3 hybridization. This is going to allow 4 bonds that are equal in shape, size, and repulsion to each other. And that is the idea here. The bonds all have to be equal. So why do things hybridize? So that the bonds are equal. Now, these are the main shapes that we are going to see with our idea of VSEPR. Linear here is going to have 2 pairs of electrons primarily. And it's going to be something like, don't A in the middle, bonded to B and bonded to B. And again, each of these lines represents a pair of electrons. So our hybridization here is sp. Why? Because there's 4 electrons in it, 2s and 2p. Trigonal planar is going to have 3 pairs of electrons. Now, I didn't make a big deal of it, but when I drew these, I drew them at 180 degrees apart from each other. So if we were to do bond angles on this, we would say that they are as far apart as possible. They are 180 degrees apart. So then it makes sense with trigonal planar here, we're going to have 3 bonds. So we'll put A in the middle and we'll bond it to B, bond it to B, and bond it to B like that. And they are going to be as far apart as possible. And as far apart as possible on this is going to be 120 degrees like this. And each of these will be an equal 120 degrees. Okay, our hybridization, now we have 3 pairs of electrons. 2 of them are from S and 4 of them are from P. So sp2 hybridization, because we have 6 electrons. S plus P plus P. Each of these makes 2 electrons. And I don't know why I'm in yellow. I don't like it either. Alrighty. Tetrahedral. Now we have 4 pairs of electrons. So A is in the middle, bonded to B, bonded to B, bonded to B, bonded to B. So we have 4 pairs of electrons around the central atom. So our hybridization here, I hope you're thinking sp3 because we have 8 electrons. In other words, 4 pairs, 8 electrons total. Now our bond angle on this is going to be between here and here, and it's 3-dimensional, so it's 109.5 degrees. And that is 3-dimensional. I've only drawn that 2-dimensionally, but it does set up 3-dimensionally. Okay, next 2 shapes here, the bent or angular shape. This one here is a bit different. It does have 4 electron pairs. Our model of that, I'm going to use A, and it's going to be bonded to 2 different things, the B and the B. And it's going to have 2 sets of electron pairs on the central atom. So our hybridization here is going to be sp3 because we have 2 bonds and 2 pairs of unshared electrons. Go back. This, by the way, this is water. Water is typical. This is its shape. If you insert the oxygen in there and put the two hydrogens down, that's what it does. Now, trigonal pyramidal is the same sort of an idea here. It's going to have uh, 4 pairs of electrons around the central atom. 3 of them are going to be bonds, like this, and then there's going to be 2 electrons like that. So our hybridization is still sp3 because we have 4. Okay, we don't have 4. We have 3 bonds. Don't do that. Cross that out. 3 bonds and 1 unshared pair. I hate hitting the edge like that. So what we have then is 8 electrons around the central atom. And so it looks like this. Remember last week we drew nitrogen and you drew this for me very successfully in almost every case. That was a trigonal pyramidal shape. Okay, the last 2 shapes are always exceptions to the rule. So these here are going to go past the past the octet. So here we're going to have 5 pairs of electrons. Obviously, it's past an octet because an octet is 4 bonds of some description, 8 electrons total. We're going to take A and we're going to bond 5 things to it. So 1, 2, 3, 4, 5. Our hybridization here is sp3, and because we need 2 more electrons, we've only got 1 s, we've only got 3 p, so the next place we would go is actually D. Now, who does this? This phosphorus does this. And again, I'm going to devote an entire day to this kind of stuff, but this is phosphorus's trick in that it can do this. And by the way, it has to be in that sort of same group as phosphorus for the most part. I'm not going to give you bond angle on this either, not to worry about. Octahedral now has 6 pairs of bonding electrons. It is A and it is bonded to 6 things, 1 above, 1 below, and then 4 around the axis. Now, on VSEPR theory, what we have here is S, P3, D2. Now, it has 6 pairs of electrons around it. 1 plus 3 plus 2 more is 6 pairs of electrons, 12 total. Who in the world would do this? Sulfur. Sulfur is your prime instigator of this shape. So these last 2 here are unusual, and we will see them as we go this week. All right, I hope you had a chance to fill in the sheet. That's all I wanted you to do, was to look at this information today. And as we go forward, we'll keep working on this all week. I know you're going to get good at it. It's a little bit much to see today. All right, take care. Bye-bye. Good luck. Hope you enjoy your Tuesday.